In this video, we are going to see the topic and the linear algebra. It is Gauss elimination method. So, previous some 3 videos we have seen about how to do the elementary transformations and the echelon form and how can calculate the rank of a matrix and how to test the consistency whether we'll get it what type of solutions. All we have seen with the examples. So just a continuous part. So similar like whatever we have done it, all the steps will carry of this method also. And here we are going to use one particular method in the Gauss eliminations method, a particular step, how we have done a row elementary transformation, same format we are going to follow it and we are going to find a solution. So basically Gauss eliminations method is defined by eliminating the elements and we can able to get your solution of the unknowns, right? So we'll see that what is Gauss elimination method. Consider a system of three independent equations in three unknowns. So we are taking it, for example, we are considering it may four equations, it may 5 equations also. Okay. So what is that? Totally I have a three independent equations in three unknowns. Okay. So it is a11 x1, a12 x2, a13 x3 equal to b1. a21 x1, a22 x2 plus a33 x3 equal to b2, a31 x1 plus a32 x2 plus a33 x3 equal to b3. The system is equivalent to the matrix equations as we have discussed before, right? The system of equations, we can be able to write it a x is equal to b, where what is there a? A is nothing but all the coefficient of this unknowns. So which will be a11, a12, a13, a21, a22, a23, a31, a32, a33. So it will come as a 3 cross 3 matrix because we have a 3 unknowns with 3 independent equations. Now, what is the unknowns? It is x is equal to x1, x2, x3. Then b is equal to the right side term b1, b2, b3. Now you can see, you can substitute all these three in this format. That means A into X matrix, the matrix multiplication, which will give equal to B. Exactly you can get this equations, isn't it? So it will come in this equations. Now, this equivalent matrix. So what we are going to do that? We are going to use the Gauss eliminations method. Okay. So we are going to learn deep stepwise how to do the Gauss eliminations, how to use the Gauss elimination method. So you can go, the aim of this method is nothing but you are going to reduce the coefficient of a matrix, that is A. This is a coefficient matrix. Okay. So matrix capital A to an upper triangular matrix. So I'm going to make it as an upper triangular. What is mean by upper triangular matrix? In the square matrix, the upper triangular matrix means only the upper part will have values and the lower terms of a lower element will be a 0. Remaining all will have a element. So we used to tell it is an upper triangular matrix. What you are going to do that? First you can consider the augmented matrix. What is your augmented matrix? A and B, right? So this A matrix and B matrix together we can take it the augmented matrix. The first step, what is the first step? Like so far what you learned at finding the rank or to convert an echelon form, what you will do? The first term, using the first row, the second row and third row, first element to be converted as a 0, right? So for that, here also we are going to use the same thing to make it the first element of any of the row to 0. You have to use your first row. Okay. So you can make it if you use the first row after simplification, sure the value will change. To make a changes, it is written a22 dash, a23 dash and b2 dash. And here also you have a a32 dash, a33 dash and b3 dash. Now again, what is that? We use the element of a11 to make the element a21 and a31 a 0, right? And at the same time, the first element should not be equal to 0. If it is a 0, you have to, what we have to do? We need to interchange it. You should not take it as a first element because entire element will go for 0, because as per the row elementary transformation rule, you should not multiple with the zeros, right? Non-zero scalar element, scalar values only are supposed to multiple. Now, the elementary row transformations, right? Use the elementary transformations, we have got it. Now, into the step 2. What is that? Again, the third row, second element to be converted 0. So, when you want to convert the second element to 0, you have to use your second row, because if you use the first row, again the first element will appear. Okay. So now step 2, we use the element A222 dash to make the element A32 dash to 0 by row elementary transformation. So if you do that, first two rows will not be any changes. The changes will happen only in third row. Now what you have to do? Use here the matrix which you have done it now, upper triangular matrix. No. So you can go with the substitution in the backward substitution. You can get this equations. What is that? A33 double dash x3 equal to B3 double dash. And similar second equation and first equation. From the last equation, I can get my x3. Once you will get x3, what you can do? Substitute in the second equation, you can get your x2. So x2 and x3 once you get, you can substitute here, you will get your x1. Okay. So what you will get x1, x2, x3 is an exact solution of the given system of equations. Clear? So we'll go with one example to compare with the steps, then it will be a more clear. So first question, solve the following system of equation by Gauss elimination method. So what is that? The equations I have x plus y plus z is equal to 9, x minus 2y plus 3z equal to 8, 2x plus y minus z is equal to 3. Now what is that? First I should take a augmented matrix. So first one I have written 1, 1, 1, 9, 1 minus 2, 3, 8 and 2, 1 minus 1, 3. So which is the equivalent matrix? What will be a first step? Making a 0 for second row first element, third row first element by using your R1. So first one R2 implies what is that? Just you can subtract it because 1 only is there. R2 minus R1. So we'll get 0 minus 2 minus 1 will be minus 3. 3 minus 1 will be 2, which is the right side. 8 minus 9 will give minus 1. Okay. The next one I have a 2. So to make it 0 here I need a minus 2. So if you are using the first row, we have to use only the first row, right? So what I have to do? Multiple to entire equation number 1, that means first row, then you can subtract it with the third row, you can get the answer. What is that? This is 2, 2, 2, he'll be 18, right? So 2 minus 2 will be 0, then 1 minus 2 will be minus 1, and minus 2 will be minus 3. After 3 minus 18 will be minus 15. Got it? Now, go for your step 2. What is your step 2 says? The minus 1 places you have to make it 0. I need it plus 1. So, you have a minus 3. So, R3 multiple with the 3. Then you can able to, what is it? Minus 3. Then you can add with your R2. You can get it. That means R2 implies minus 3 R3. Because I should have here plus 3 and minus 3 will be 0. Okay. So, for that reason, you have multiple with a minus 3. That's all. Just you can add it. You can get your 0, 0, 11 and 44. Now, use your backward substitution. I'll get x plus y plus z equal to 9 and minus 3y plus 2z equal to minus 1 and then 11 is equal to 44. Now, what is that? From the third equation, z is 44. Use this z, substitute in equation number 2. I can get your minus 3y plus 8, right? So, 2 into 4 will be 8, which is equal to minus 1. So, y will give equal to 3. Then, use your z and y value in the equation number 1. You can get, see your x is 2, right? Sorry, x plus y is 3 plus z is 4. So, what is that? I'll get the first equations, okay? So, x plus y is 3 plus what is your z? Z is 4 which is equal to 9. Now, you can see x is equal to, this is 7, right? So, 9 minus 7 which will give equal to 2. That is what we have done. X is equal to 2. Okay. So, that is for your x, y, z value we found it. Now, you can go with one more example. Apply the Gauss elimination method to solve the system of equation. So, it is 2x plus y, 5y plus 7z equal to 52. 2x plus y minus z equal to 0. X plus y plus z equal to 9. So, basically the before into the augmented matrix or you can see that equations how it is there. See to that the first entry of the first row, if it is 1 is already is available, better you can interchange it. Okay. already you can see the coefficient of first one 2, 2, 1 is there. So what I'm going to do that, I'm going to interchange here third and the first. Okay, that's what has written the augmented matrix in the solution. The first one is shifted there, 1, 1, 1, 9. Okay, so 2, 1, minus 1, 0, 2, 5, 7, 52. Now what will happen? What you have to do, can make it a 0 for second row and the third row first element by using your first row. That is what is done. Multiple with 2 and then you will remain same. Just you subtract it with your R2 and R3, you can get your 0, isn't it? So R2 implies minus 2 R1 plus R2. So we will get 0, 2 minus 2 0, then 1 minus 2 will be minus 1, minus 1 minus 2 is minus 3, and then minus 18, right? The next one, what is that? 2 minus 2 will be 0, 5 minus 2 is 3, 7 minus 2 is 5, and 52 minus 18 is 34. Okay, now the next one, 3. This places you are going to make it 0. Just to multiple with 3 in R2 and you can add it. R3 implies R3 plus 3 into R2. So what is that? 1, 1, 1, 9, 0, minus 1, minus 3, minus 18, 0, 0, minus 4, minus 20. Okay, because 3 minus 3 is 0, and then here you have a 5, and 5 minus 9 will be a minus 4, and the remaining you will get for the minus, this minus 18 into 3, then plus 34 will give a minus 20. Now x plus y plus, you have to use, what is that? We reached it, upper triangular matrix, right? Once you reach your upper triangular matrix, what you have to do? We are going to substitute the backward substitution. X plus y plus z equal to 9. So what is the second equation? Minus y minus 3z is equal to minus 18. The third equation is minus 4z equal to minus 20. From the third equation, what I can write it? Minus minus will get cancelled. 20 by 4 will be 5. I got it, is it? So what is your second equations? To get your y value, substitute your z value. Minus y minus 3 into 5, which is equal to minus 18. So simplify that. What is it? Minus y is equal to, here it is a 15. It will go the other side. Minus 18 plus 15, isn't it? So you have a minus 3. So y will have a plus 3. That's what is written. Y is equal to plus 3. Now it's coming for the x value. How we will calculate the x value? From this equation? From this equation we are going to calculate your x value. What is that? X plus y is 3 and z is 5, which is equal to 9, isn't it? So what is that? 3 plus 5 is 8. So x is equal to 9 minus 8, which is equal to 1. So you will get x value is equal to 1. That's what we have found that x, y, z will be 1, 3, 5 is in your exact solutions. Okay, so basically the Gauss elimination method has been used to find solutions of your system of equations. That's all. Thank you.